All right, so hopefully, within the next maybe 10 minutes or so, let me finish the implications so we're able to move to your project. All right, so here, really, I'm trying to put everything together so it's less, so I hope it's more connected, all of the terms that we have talked about so far. Just now, we defined all of these terms, but we have not yet talked about, what do you mean by adding a random noise based on differential privacy guarantee, right? So in this section, really trying to connect the added noise, like the noise to be added. We want to show you two important implications. One is about how the added noise is related to the sensitivity, which is the L1 sensitivity that we talked about, okay? The other one is how the added noise is related to the privacy budget, okay? So as you can see from here, that the added noise will depend on the sensitivity, L1 sensitivity, will also depend on privacy budget, okay? But then if we come back to what we just did earlier, we know that, well, sensitivity depends on the database and the query, right? Privacy, yes, it's sort of a privacy budget is set by predetermined, set by somebody, maybe not yourself. So we want to connect all of the terms together to give you a sense of what we're trying to do, okay? So to start, we know that with given privacy budget epsilon, we can add noise according to the differential privacy definition to the output, right, in order to preserve privacy. So exactly how to add noise, we're gonna leave it for next week. But today we're gonna finish talking about how we can think of how the sensitivity is affecting the added noise and how the privacy budget is affecting the noise. We put the results first, right, the conclusions first. Here, the added noise is positively related to sensitivity, meaning that if you have a larger L1 sensitivity, you have to add more noise. Okay, that's what it means. And then the second is the added noise is negatively related to the privacy budget. That means that if I have a lower privacy budget, I have to add more noise. If I have higher privacy budget, I have to add less noise. Okay, so let's go into the details of each of the two to make sure that makes sense, okay? So first of all, sensitivity and added noise. We know that L1 sensitivity is of a query function f. It is to capture the maximum change a single individual's data can do to the L1 norm of the query function, right? And we know that we use delta f to denote it. So we know, first, we talked about it just now, L1 sensitivity depends on the database and also the query, okay? So for example, a count query, we know that delta f is 1 regardless of the database, right? We talked about this. So, and the average query is b minus a divided by n, and we know that it will depend on the database, not so much about a and b, but at least depends on database about n, because n is the number of observations there, right? And a and b, like we said, actually should not be, later I will change this, should not be depending on the database, but it should be, well, when we say not depends on the database, it's not saying that A should be the minimum of the value and then B should be the maximum. A and B should be the possible minimum and possible maximum in the universe, not about the database itself, okay? All right, so clearly we have a constant delta F here, right? And we we don't know how large the delta F for the average query will be, but probably will be something large, right? Because if you think about the possible range of people's income in the United States, well, it could be large and then divided by n of that. So for this two queries, I'm throwing maybe, because this two that we talked about, one is about count, the other one is about average, so it's less comparable. So let me show you two queries. One is the first one that we talked about, the second one we talked about, the average income of this sample, and the second one is the average expenditure of this sample, okay? So just so you know, delta F, if we have the, for same level privacy protection, that means that if we have the same epsilon, if we're claiming, okay, that larger noise is needed for larger L1 sensitivity, and that's what we're saying. The first implication is that sensitivity and added noise, they are positively related, okay? So if we consider these two queries on the screen, One is about the average income of the sample. The other is average expenditure about the sample, okay? So for a given fixed privacy budget, epsilon, which query has a larger sensitivity? Maybe instead of sending to breakout rooms, which one will have the larger sensitivity? So we know that both of them are average, right? So both of them will have the form of b minus a divided by n. So so then that becomes, so both of them will have a delta f in this form, right? Because they're both average. Okay? And what's the same? The same thing is the n, because it's the same sample, so they have the same number of observations. I guess the question now becomes, which one will have a larger range of b minus a? Just based on the variables themselves. What do you think? One is about income, the other part is about expenditure. Intuitively, which one will have a higher range?
Probably income.
Yeah, I would agree with that. Intuitively, right? I mean, expenditure most likely will be part of the income that you spend, right? So income naturally will have a larger range. So with a larger range, so again, we're not talking about actual maximum income and minimum income and actual maximum expenditure and actual minimum expenditure in the data set. We're just talking about, well, in the universe, how we're thinking about this. Okay, so let's just maybe take that for now, that income will have a larger sensitivity. Okay, and then with that, well, which query you think will need a larger noise to be added? Well, I already wrote it down, but does that make sense to you? When you have a query that will have a larger, higher sensitivity, and then we want to achieve the same epsilon, meaning that if you go back to the definition of epsilon, maybe let me do that for you. We want to bound this. Oh, it's hard for me. Where did I have it? I have it 2 slides ago. Yeah. We're trying to bound it about with the same epsilon. Okay. So with a larger sensitivity, because it's a wider range to cover, we will need to add a larger noise to it. Okay. So yeah, hopefully this gives you an overall sense. Actually, later you will see how mathematically the sensitivity is related to the noise. Okay, but for now, we want to make sure that you get an intuition of how you can think of sensitivity and added noise, and of course the second implication that we're going to talk about soon. Okay, so the sensitivity and the added noise are positively related. Okay, if you fix the privacy budget, that is fixed, then larger sensitivity results in larger added noise if we want to provide the same level of protection. And the other one is the privacy and added noise. Okay, so epsilon differential privacy provides an upper bound. We know the upper bound itself is epsilon, the privacy budget itself. Okay, and we also know that privacy budget should be determined beforehand, in a sense that it does not depend on the database or the query itself. Okay. All right, so question for you. What is the relationship between the privacy budget and added noise given fixed L1 sensitivity? Meaning that, okay, if I'm dealing with average income, okay, I'm thinking about two different values of epsilon. Let's just say one of them is 1, the other one is 10. What happens, oh, sorry, let me just follow the question that I wrote down. Given fixed L1 sensitivity, meaning that, say, we're dealing with the average income for the sample, what happens to the added noise when epsilon increases? And what happens to the added noise when epsilon decreases? Okay, think about epsilon is the upper bound. Okay, it is the upper bound on the noise necessary to be added to the output. So we know that it's the log probability of the outputs after we apply the mechanism add. to X and Y. Okay? And X and Y are only differing by one record. So if my epsilon increases, meaning that I'm going to have a higher budget, should I add more noise or less noise? On the other hand, if epsilon, the privacy budget, decreases, should I add more noise or less noise?
Since if you're saying that your private budget is smaller, then you would want to have more noise.
Mm-hmm.
So yeah, like so like the larger the budget, you would have less noise.
Sounds good. Yeah, so if you look at the equation here, epsilon we know is the bound, right? So if we decrease this, we're allowing less change, right, between the two outputs in some sense, if you think about the log probability, the log probability ratios here. So in order to make that happen, you have to add more noise to the output, because I do not allow them to change that much in some sense. So if that is the case, then if my epsilon decreases, I have to add more noise. If my epsilon increases, I don't need as much noise as before. Okay? Another way to think about it, as you know, is we actually we name it as budget, right? So you can think of it, the budget is high, we are more flexible in the sense that we don't need to add much noise. Okay? If the budget is low, then we'll have to add more noise to make it happen. So things might sound a little bit vague, like I said, but we will show this mathematically next time, and you will see that what we mean by how these two are related to each other. Okay, so in sum, privacy budget and added noise are negatively related. And a quick summary here. We know that for differential privacy, we're working with summary statistics. Okay, they're the outputs. Okay, so the key is to add noise to the output of queries made to databases. We are adding noise randomly, and the noise depends on a predetermined privacy budget and the types of queries. Okay. We have covered two important implications. Added noise is positively related to the sensitivity and negatively related to the privacy budget. Okay. And because of that, next time you will see that when we do this Laplace mechanism, which will satisfy epsilon differential privacy, when we actually add Laplace noise to summary statistics, for example, if we count an average, we'll have to make sure that the noise that we, like the Laplace noise that we add, is scaled to positively to the sensitivity and negatively to the privacy budget. Okay? And from there, you can see how we can add noise to summary statistics. Okay, so in the handout, I think I included the Laplace mechanism, so maybe some of you checked it out already. But next time, we're gonna talk about that as well, some of the properties of differential privacy. And also, as you notice, we're not talking about generating synthetic data at all at this stage. Okay, we're just talking about how to think through the lens of differential privacy about adding noise. But of course, there are many basic foundational definitions here about privacy budget, and then about especially what do we mean by two databases differ by one record, and how can we think about that, and how that factors later into the noise itself will be the main topic for next time. Any additional questions before we move to the project? Okay. All right, if not, let me